Okay, hello everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today on our webinar. We have an exciting topic today. It's called Mocking NASA's Mars Weather Service API and more with Mockintosh. And I already got my own quick preview beforehand, so I can tell you that it is fascinating. Yes, it is being recorded, and I'll talk about that in a second. But first, I want to introduce our speaker. Our speaker is Mert. He is 29 years old, but you wouldn't believe it when you hear him speak. He's a computer engineer. He's from Turkey. And over the past years, he's contributed to lots of open source repositories, including Wikipedia, Moodle, and 3 Blue 1 Brown's animation engine. He's also the creator of Dragonfire Virtual Assistant and the Chaos Programming Language open source projects. And for the past year, we've had the pleasure of working with him at Up9, where he's been a software engineer and also the lead developer of the Mockintosh project. Now a little bit of housekeeping. So like I said, and to answer the question that pops up here, yes, the webinar is being recorded and you will get the link afterwards. There's also a Q&A button. You can see it at the bottom panel and you can click on it and ask any questions that you have. We'll have a Q&A session in the end, but you can ask at any time whenever you have a question that comes to mind. And we'd really appreciate your feedback on how we did and which other topics would be interesting for you to hear and learn about, because that's how we curate our webinar schedule. And with that being said, I'm going to pass it on to Mert.
Okay, thank you so much, Noga. Hi, everyone. Welcome to the third webinar of Mockintosh. Let me summarize what we are going to do in this webinar. We'll explain what is Mockintosh. We'll mock NASA's Insight Mars Weather Service API. And then we will mock WeaveSock's microservice demo in a funny way. So what is Mockintosh? Mockintosh is a service virtualization tool that is capable of generating mocks for RESTful APIs and communicating with message queues to either mimic asynchronous tasks or to simulate microservice architectures in a blink of an eye. So we support RESTful APIs, we support RabbitMQ, Apache Kafka, Apache ActiveMQ, Redis, Google Cloud PubSub, and Amazon SQS as the message queue backends. How do I install Mockintosh? Just a simple pip install Mockintosh is enough to install Mockintosh. The hello world in Mockintosh probably looks like this. So this is, for example, an HTML template that contains some handlebars syntax to generate an HTML as a template render. This is a config file that contains 3 endpoints separated into 2 microservices. And there are references to other files from like these @ signs. There's a reference to this index HTML, or it might be a JSON file. That is another template that's written in Jinja 2 to generate a JSON response. So the result of that HTML render looks like this. And the values that are written in bold changes every time. So it's basically fuzzing the output. And the JSON response of that JSON template looks like this. And also these values are changes randomly for each response. So let's start by mocking NASA's Insight Mars Weather Service API. But why are we mocking that API? So, I'm sorry, NASA's Mars Insight mission project provides an API that returns the weather report in Elysium Planitia region of Mars. This API got a major breaking change recently, so that even though you supply the version 1.0 query parameter, the response is quite different when it is compared to its previous state. The old API is moved to a different domain for some reason, and this endpoint does not even require an API key, which is a fun fact. Normally, the NASA's API requires an API key to consume, and there's a rate limit. But in this case, I guess there's no rate limit. As a result of this change, many clients that depend on this API are now broken. So these are all the old clients that are open source projects that consumes that API, but now they're broken since the API changed drastically. One of these clients is Adrian Appen's Mars Weather service, a Mars Weather Insight app. Let's say Adrian realized that his client is broken and didn't realize that the old API moved from api.nasa.go to mars.nasa.go. What would Adrian do if he really needs to revive his client without changing the code? That is where Mockintosh comes in. The React app is broken. So if we start the app with npm start, you can see the app is broken because of the breaking changes in the API. So this is the demonstration that shows an error, a React error because of the changes in the schema of the API. And the difference is side by side, old versus new. So the old API that the clients were using, the endpoint, were returning a response like this, while the new version returns a response like this, which is completely different. And this is how I found the old API in a new URL. So I searched for the different web pages, and I eventually found this one. And the old API actually resides in this endpoint. So let's start coding. So first, we need a config YAML file like this. The templating engine is Jinja 2. The management API and a web UI will be available on port 8000 with TLS or SSL enabled. We have a mocked HTTP service that will be available on port 8081. Contains an endpoint with path /RSS/API to serve the response. The endpoint expects to see these key value pairs in the query string. Otherwise, it does not match to the request. So these are mandatory fields with those mandatory values. Otherwise, the request is not matched by this endpoint. It always responds with status code 200. Sets the response header content type to application JSON. And renders a JSON Jinja 2 template from a relative path, relative to the config file, by the way, that this path is relative to the config file, and sets the HTTP response body to that render result. So this is a template, JSON.j2 file. So we also need a response template like this for the response of that endpoint. With this for loop, we generate the JSON object that is encapsulated by the loop for 7 times. The values between 675 and 671 serve as the sol indexes, and sol means a solar day on Mars. It starts from November 26, 2018. So that day is sol 0. So the whole calendar of Mars starts from that date. This JSON object is per sol atmospheric temperature sensor summary data. AV means average of samples over the sol. CT means total number of recorded samples over the sol. MM means minimum data sample over the sol, same units as AV. MX means maximum data sample over the sol, same as the AV. We mock these values using random template helper object. So we, whenever there's a floating point number is needed, we use random.float. If it's an integer number is needed, then we use random.int helper. First UTC is the timestamp of the first measurement, and last UTC is the timestamp of the last measurement of the sensors. We mark these timestamps using Faker. So we generate a random date and a random time with a desired format and perform string concatenation to put them together such that they become a timestamp string. This JSON object is parasol horizontal wind speed sensor summary data. It's marked in the same way as we marked the atmospheric temperature data. So the format is like exactly the same. We just changed the key because keys are static values. They're hard-coded. There are 6 seasons in Mars: early winter, winter, late winter, early summer, summer, and late summer. We mark these values by randomly selecting elements from a given list and performing string concatenation afterwards. So we select early, late, or nothing from a list of strings randomly using Faker. And then we select winter or summer from another array of strings. And then we concatenate them to get the desired value. This JSON object is parasol atmospheric pressure sensor summary data. So again, it is the same thing. The key is changing for the atmospheric pressure. This JSON object is parasol wind direction sensor summary data. It is marked in a bit complicated way, but it's actually easy to understand. The API always returns the 0 and most common keys, so we hard-coded them. Then between 1 to 19, we generate more keys and fake the compass sensor measurements, such that we have 3 objects in the same format. First one is static, last one is a little bit randomly generated, but key is static. And the objects between those two are randomly generated. Like there could be only 1 record, or there could be up to 19 record. Like it varies from response to response. So we again fuzz the response. And like again, we are using random float or selecting an element from a string array using random element. These are the compass directions, these N, NE, etc. And again, there are other floating point and integer values. So the API is designed in such a way that the clients need to know the possible sol indexes to fetch the data from the root JSON object. So we generate a list of sol keys in the same way as we generated the sol keys previously. So, so we are generating the same for loop. I mean, using the range, we generate exact same sol list to provide clients about the information as the information of what are the sol indexes that are coming with this JSON response. And validity checks serve no purpose in our subject client, but they act as the information of validity criterion of sensory measurements that are in the returned response, so that sol hours required is the minimum number of hours of work of a sensor per sol for the measurements to be valid. Sols checked contains the list of sols that were checked against the validity criterion. So this is the data about how the measurements valid to how much degree. So it can be used, but our client does not use it. So let's try our React app again. So let's start Mockintosh with Mockintosh mock /config.yaml. with the verbose flag and see the result. So we started. I guess you should be able to see the full screen. Yeah. So we started Mockintosh. We started the React app, and now it works because we fully mocked the old version of the API and replaced it in our client's configuration. So all the data comes from the mocked service and not the real service. So these are the render outputs that are returned by the Mockintosh. When you use the verbose flag, we print debugging outputs, and these outputs are printed to inform the user. And the second part, mocking WeaveSock's microservice demo in a funny way. And yeah, this will be the funny part of the this mocking task. So this is a well-known open source microservice architecture demo. The architecture consists of 8 different microservices: carts, catalog, front-end, orders, payment, queue master, shipping, and user. What are we going to do? We will mock the catalog service and remove this dependency completely. This is for demonstrating the fact that a microservice developer does not necessarily need to depend on another service while developing his or her part. Then we will partially mock the front-end service to rebrand the whole project in a cat theme. Lastly, we will create another mock using Mockintosh's unique asynchronous actors feature to constantly push a new shipping task to a RabbitMQ queue, with the purpose of simulating a situation where there is a high traffic on the website and a lot of orders are placed. Therefore, we can see how the system behaves under such a load. So I should bring water. The catalog service has 4 different endpoints. So get catalog /ID, get catalog / size, and tags. Each responds with a JSON such that their content type header set to application JSON always. And we have generated a draft of this mock automatically from the Swagger /OpenAPI specification of this service that was available inside the related WeaveSock's project. And then we further modified it by hand to perfect it. So, and the command for transpiling a Swagger file to a Mockintosh config is this. By the way, the transpiler is like kind of an experimental feature. So it does not perfectly translate an OpenAPI specification to a Mockintosh config, and probably never be able to perfectly transpile, but it's like partially transpiles it, so you should modify it by hand at the end of the day. And this config has references to 4 different response templates. As you can see, catalog.json, catalog.json.j2, id.json.j2, size, and tags. And these templates are designed to perfectly replicate the responses of those 4 different endpoints. So these response schemas are relatively simple compared to, for example, the weather service API. So they are shorter. We just fake the values in the JSON fields. And if there's a list, we again use for loop to generate a number of records. The front-end service, the mock for the front-end service is quite simple. We're just replacing these 5 images with some other custom image. The interesting thing about this mock is that we forward every unmatched request to the original front-end OREG service inside the Docker network, so that we only mock these 5 URLs and nothing more. So, we basically override the URLs that only we want to change. So we don't replace the whole service. We just partially replace the service with this mock configuration. And fallback to field is the field where we define the address of original front-end service. So front-end OREG is the name of the container in the Docker network, and the port number, we specify the port number, and fallback to handle all the forwarding of the requests that are not handled by our mock. And the shipping service consumes the shipping task queue from RabbitMQ and takes actions according to the messages that are consumed from this queue. So to trigger the consumer that is implemented inside the shipping service, we're going to use the asynchronous actors of Mockintosh. We define a producer type actor. The actor is triggered for every 2 seconds until it reaches its limit 1000. Once this actor is triggered, it creates the shipping task queue if it does not exist. It produces a message that's described by the key, value, AMQP properties, and headers fields. So the content of the message is a JSON, and the content type is specified through content type AMQP property. There are a lot of AMQP going on because RabbitMQ uses AMQP protocol for its communication with its clients. So AMQP properties is specific to AMQP protocol. The other protocols does not have that, but key value headers are common across all protocols in Mockintosh. The value in type ID field is the Java class path of a Spring Framework entity defined in the shipping microservice. Whenever the message is produced into the queue, the shipping service consumes this message as soon as possible and takes action accordingly. And the Docker Compose YAML that we also need to edit to put our Mockintosh replacements of those services. So here is how the Docker Compose YAML file is modified. Highlighted places shows the additions. We used up9 inc /Mockintosh, latest official Docker image. We have mounted a volume to pass the config YAML and templates into the container and specify the config YAML path in the entry point command. So these volume definitions are there for mounting our files, our templates, and the config YAMLs itself into the container. And with this parameter, we tell Mockintosh to use this config YAML from the given path. So it starts with that config YAML. And we kept the old front-end service and renamed it to front-end OREG. Remember, the address of original front-end service is defined with the fallback to in config YAML. So this is the service that is added by us. This is the old service. We renamed it. So we define a fallback to in the config, in this config file, such that all the requests will be forwarded to this service. But all the requests are handled by our Mockintosh instance. So this is how you should set up Mockintosh if you are going to partially mock a service, not fully, partially mock. Because we were mocking Catalogue fully, but front end is partially mocked. We kept the old shipping service and renamed it to shipping old again. This is the same thing. Remember, the address of original shipping service is defined with the fallback to in the config YAML. The same setup for the shipping. And let's run Docker Compose up to see the results. So let's run it and see the results. So all the containers are becoming available. And we visit the website and we refresh it. The values and images change randomly, but the website is again fully functional. Like the whole add to cart, etc., remove it. These kind of, this is the e-commerce website example, so it's fully functional. It's just mocked, so such that we have removed some dependencies. So, and if you look at this part, that we are pushing some shipping tasks into RabbitMQ every 2 seconds. So this container, the shipping container, also works. Yeah, so this is the, and you can find our fork of ViewSox demo that contains the mocks at this repository if you want to replicate the results that we are having in ViewSox on your local machine. And let's start a Q&A session. Yeah, yeah, please don't hesitate to ask questions if you have any.
Thank you so much, Mert. It was fascinating and so full of information and like valuable information that I'm sure will help everyone who attended and everyone who sees the recording afterwards. If you have any questions, this is the time. You have the Q&A button, or you can ask in the chat. Don't be shy. Feel free to ask anything maybe that wasn't clear, just any ideas that you had that you'd like to share. In the meantime, I'll tell you that you can follow our LinkedIn profile and get information about upcoming webinars and blog posts that we post, and in general, everything that we're doing and what we're up with. And Mert will move on to the next slide and show you how you can get more information about Mockintosh. If you go to, right?
Okay.
We'll let people ask questions in the meantime, but you can go to github.com/upnining/Mockintosh, read that documentation, of course, try out Mockintosh for yourself, give us a star, and of course, see the documentation. We have a dedicated website, Mockintosh.io, or just contact us. Mert, did I get all that correctly?
Yeah.
Great.
Perfect.
Great. I don't see any questions yet, so we'll give it another few seconds. And if not, we'll just let people contact us directly.
All right.
All right, then. Thank you for joining us today. Like I said, we'll get the recording, and feel free to reach out to us at Up9 for any questions, and of course to try out Mockintosh for yourself for mocking NASA or just any software system that you have and build for yourself. That's it. Thank you so much.
Thanks so much.
Thank you, Mert. Thank you. It was great.
Thanks so much. Bye-bye.
Bye-bye.